Hello and welcome to this section on formulas and solving for literal. So let's review some simple formulas that we will encounter. This is by no means exhaustive list, but it's a list nevertheless. So let's start with things with some simple ones. So for example, the area formulas, right? So we can say the area of, for example, a square. Right? So a square is something that has four equal sides. I don't think that looks very square, but nevertheless, I'm attempting to make it four equal sides. And S, let's say, is the length from there to there, and so this would also be the length from there to there because it's a square and four equal sides. So the area of this, and sometimes we just say A for area, is equal to length times width, and that is S times S, or some S squared. Now if we went to a rectangle, the sides don't have to be equal, so this length here we can call that the length, and we can call this W the width, length, and so area now is L times W. So you probably knew all this, but I'm just reviewing some basic area formulas. Area of a triangle. So let me draw a triangle. So there's my triangle. Now the area of a triangle is found by finding this height here. That height there is called height of the triangle. And then this is known as the base of the triangle. And so the area is equal to 1/2 height times base, or we know from the commutative property this could be BH as well. What else? Area of a circle. These are all formulas that you might encounter. There's my circle, no laughing. There is the radius, and the area of the circle is pi r squared. And if you connect this back to types of numbers, we know immediately, since pi is irrational, area is also going to be irrational. Some other formulas could be the formula for perimeter. And so perimeter of a rectangle, so here is a rectangle. We have length and width. Now perimeter means the length. So let me write this down. Perimeter means length along the border, right? So imagine you are walking along the border of this. How far would you walk, right? That's perimeter. So P perimeter would be, well, if you started here, 1L, and then you'd go up this way, that would be another W, and then you'd go back that way, and that would be another L, and then you'd come back to where you started. That would be a W. And so if you combine like terms, that would be 2L plus 2W. I'm going to do a quick example of this. Example, imagine you had a rectangle with one side 4 meters and the other side 2 meters. Now, so the perimeter of this, we could find it using the formula as 2 times the length, which is 4, plus 2 times the width, which is 2. So that would work out to be 8 plus 4, which is 12. I personally, this is just me, I personally figure this out, meaning I imagine myself walking along the edge from start to finish and then write down the perimeter. And the reason I do that is, as my kids would say, you're old and you can't remember things, and that's probably true. So anyway, 4 plus 2 plus 4 plus 2, length, width, and then that takes me to 6, and another 6, which is 12. So you get the same answer either way. It doesn't matter how you figure this out, but perimeter is important. And it's important because later on we'll be doing problems using perimeter, and often students forget the 2 that's in front there. So keep in mind it's the length along the border. Now in this section you'll also be asked to, you'll be given a formula and asked to solve for some of the letters. So for example, consider the area of a triangle formula. So A equals 1/2 BH, and it might say solve for H. So in this case what they want you to do, solve for H, means isolate the H, or get the H by itself on one side, right? That's what solve means. So you go back to all the things we've learned about solving equations. So first of all, when I look at this, I see a fraction. So I'm going to clear the fraction. So to clear the fraction, I'm going to find the LCD. So the LCD, the least common denominator, is 2. So I'm going to multiply everything, left side and right side, by 2. So 2 times the left side, 2 times the right side. And if I did this right, this is 2 over 2 BH, and this fraction reduces, and I get 2A equals BH. Now remember, solve for H, right? So once you cleared the fraction, you can now think about solving for H, isolating the H. So how can I clear the B out of there, right? What is the multiplicative inverse of B? So that would be 1 over B. So I'm going to multiply both sides by 1 over B. So 1 over B on the left side times 2A over 1 equals 1 over B on the right side times BH over 1. And so we can do the multiplication, multiply across 2A over B, and over here this is B over B, H, and of course the B's cancel. So we get H equals 2A over B. Now I've done it very slowly. Some of you might be able to do it faster. But the big thing is, don't forget that you can always clear a fraction from an equation. This is something we learned in the previous section. Let's do one more example of solving for a literal. And the formulas you get don't have to be formulas that you worked with. So for example, if I said solve A equals M plus 2D over 3 for D, right? So we want to get D by itself. But again, this is a formula with a fraction. So let's find the LCD. LCD is 3. So I'm going to multiply both sides by 3. So 3A equals 3 times M plus 2D. Remember, this is just fractions, although the fractions look complicated, right? And we can multiply or cancel these 3's, and I get 3A equals M plus 2D. Now to solve for the D, I could subtract M. So I get 3A minus M is equal to 2D, and then divide by 2, and I get D equals 3A minus M over 2. And that's how you solve for D. So we don't have to know the formula. So in this example, we don't know what the formula is, but we can still, for all, do the problem. All right, that's it for this section.